you, everyone. Excuse me. Thank you, everyone. It's a pleasure to be here. A big thank you to KLH and ALH. Really enjoyed so far all the speakers. I particularly love Jason. I do love telehandlers, so that's near and dear to my heart. So thank you. We won't talk about telehandlers today. What we will talk about is ducks, people, and obviously big data. So we're talking about how artificial intelligence is going to improve our industry. We all know about artificial intelligence and the impact it's having across many different sectors. We do know that it increases productivity, it increases efficiency, excuse me, and it also reduces operator error and reduces the impact, the potential for people to make human mistakes. We know with technology that devices will get smaller, will get more powerful, and eventually they'll get cheaper as well. So we see that 108%. We are seeing a big increase in funding for AI, and we're going to start to see that impact as it comes through. Throughout today, I want to also reinforce the importance of the human involved here. It's not just the data that we want to look at, it's how that impacts and what is the outcome and how we can improve the outcome for the operator. A little bit about EQSS. We're an Australian company. You might have picked that up with my accent. We've been around for 18 years, mostly in telehandlers, doing very similar work to Rika. We're also providing safety products. We have a duck there because I like to describe how we do our work. The products that we do is a lot like a duck swimming on a pond. Right? At first, it looks rather simple, and it's deliberately really simple for the operator. Simple to use, simple and straightforward. Right? Enables the operator, the worker, to continue to do their work. But underneath, like that duck swimming, it's very sophisticated, and there's a whole lot of complex calculations and algorithms being used. So just like a duck, we want to keep it straightforward, but that doesn't mean that underneath it there's not a lot of high power there. We make a range of products, as I said, and I'll try not to make this a little bit of speech. For me, EQSS, I've been there. I work in global business development, but I am an engineer, a mechanical engineer, and I've worked across this access industry at IPAF and at one of the major OEMs as well. Now, with AI, when we start to talk about data, we often talk about big data. We have to think about how that can improve our actions, how that can improve the worksite in a number of different ways. We can learn from accidents. We can better understand operators' actions and how they use the machines. We can identify hazards in real time. We can track behaviour and recognise mistakes on bad practice, recognise those mistakes before they actually turn into an accident. We can build safer work sites and perhaps even improve and build better machines as well. And lastly, we can keep the machine in a safe working conditions. These are all the different ways that the data can be used. We see with the data that there's what we call the four V's that have a major impact on how we can use that data. Right? Velocity, volume, variety, and veracity. Right? So we all hear about, and particularly anyone who's used telematic systems, the volume is of the data. So much information comes in at such speed. And we need to know, it's often a whole different range of information. And we need to make sure that that information is correct and true. So these are the important aspects to bringing that information in and identifying how we can best use the information. Often we talk about with AI is why it's not just the information, the data, it's about what we can learn from it. And AI particularly is perhaps defined as how it recognises pattern in the data. It identifies using machine learning or deep learning and starts to see these patterns and to be able to make decisions at a far faster pace and are far more complex than humans would be able to do. Important thing that we have with any of this, and is the sensors, is how we get the information in. And we'll see it's not just a simple matter of putting on a little parking sensor at the back of your car, taking that off and putting it on a boom lift and identifying where things are. The sensors are critical in terms of being able to have the right information, and that, as I said before, the correct style of information coming through. Right? So effectively it comes back to that the classic phrase of garbage in and garbage out. I'll just go back one. We also see processes, and with so much information and such a high level of complex detail involved there, being able to have the right processes is also something to consider. We all have heard about cloud computing, the concept of being able to take information, take the data up, and be able to do the computing at a higher level. The difficulty with that is obviously the connectivity, especially on a work site where it's always a change in work site. It's not even in one stable situation. So being able to use cloud computing and networking and the connection can be quite fraught. Alternative is something coming through now we have is fog computing. Fog computing, which is not at the same high level of cloud computing, but down at a fog level, is down at the local level. And that requires high-level, small processors being able to do that on the machine itself. So we're going to probably see a mix of fog computing where all this calculation has been done on the machine, and being able to connect into the wider worksite and being able to use that through as well. AI 4. There's effectively 4 pillars to the use of artificial intelligence. Right? I'm going to try and remember them as we go. So the first one is the sensors, is getting how we identify what the information is, how we read the external environment. So we have the outside environment and bringing that information in. The second pillar is the information itself, the data. How we store that, making sure that we keep that in a usable format and keep that coming through. The third pillar is the analysis, is that processing power and the data management and all the algorithms used to come through there. And the fourth pillar, and this is probably the most important one, and not one that I feel is talked about often enough, is the human interface. Because all very well to have great sensors, all very well to have great machine learning and coming through and identifying where the issues are, but we need to be able to see how that impacts for the worker, how we can make something simple and useful to the person at the end. So we often see the advantages of AI. We see on our phone how a great interface is so important for us humans, and we'll see that too on the machine level. So there are our 4 pillars. I tend to feel that we're coming through into a new phase, and I say, that was when we talk about the machine condition, where we understand what the machine is, and that's pretty much where we've seen a real enormous growth over the last 5 years through telematics. We can identify where the machine is, what the fuel level is, and whether it's being used. At some point, we want to get away from that machine condition. We want to go even further along. So we can start to see how we can improve their safety level, how we can improve how people are using the machine, and how the machines themselves are interacting and becoming more effective. It's not just about the safety improvements. We see some significant effectivity improvements and production improvements coming through. And I'll go through again. All right, so now we probably get to a little bit more interesting phase. I'm just going to briefly discuss some of the different innovations that we start seeing that are starting to come through to the wider workplace. We have the ability now to monitor work sites and to really identify where the machines are and where people are. We're talking about constant coverage and immediate analysis of the activity. Major difficulty we have, of course, is how we can then connect to the machine. There's no point just having a camera that sees a digger driving over a pedestrian, right? Or seeing something connecting to a power line. So the connectivity from here is one of the more difficult features, another obstacle to pass. But so this information is obviously gathering a huge amount of data, and we're starting to say, well, what can we do with that? Where can we take it from here? Another one where we all know virtual reality and augmented reality is coming through. Some of the major companies, such as Trimble, have some terrific products that are really coming into use. If you start to think about the access industry particularly, are we going to be able to have the ability to have augmented reality or some screens coming through added to the machines to really enable the worker to see the future, see what the build requirements are, and to come through on there. For sure, the interaction with the 3D scans and being able to identify where there are some safe and unsafe areas to access is definitely going to come through in the next couple of years. No surprise, of course, material handling is a clear and easy win in terms of new technology. We have a robot moving the materials around. For boom lifts, we're starting to see winches and other mechanised lifting products being put into the work platforms themselves. And it won't be long before we start to see that them being connected and providing additional, integration to the wider industrial sector. A little one, this is a little bit what we do, so operator monitoring. This is particularly for scissor lifts. We see over the last 8-10 years on boom lifts, there's crush protection. It's often called secondary guarding, and it's there designed to reduce the risk for the operator to be crushed while they're working at height. On scissor lifts, we've got this product called the Overwatch. In Australia, it's been a very significant issue over the last 5 years. So this Overwatch we have for the last 3 years, it monitors where the operator is positioned. And there's a little GIF there. That doesn't have an Overwatch on there. But yes, when someone gets caught, they get crushed when they're working at height. We need to be able to stop the machines. We need to be able to know when to stop the machines and when to allow the worker to access it and to move into the right position. This system uses a LiDAR monitor, and it's mounted onto the side of the control box. It doesn't look at the environment. It doesn't worry about where you're used, because the scissor lift has to go up into all manner of places. But what it does do is consider where the human is positioned, make sure that human is in a correct position to use the machine, and as long as they're in a safe position, then it allows a movement to occur. And then if the worker moves out of the way or gets caught or gets trapped, it immediately stops the machine and prevents a serious or fatal incident occurring. Of course, there's a whole lot of complexity about that, and it's not something we just. It takes, as I said, huge amount of sensing and data and that processing to come through. Another one, and this is one I really like. It's another Australian setup, and is that there's an app that provides the information for where all power lines are. Right? And this little app, it's made by a fellow named Cookie, and he asked me to say that he's really available, really wants to take this to the US as well. It's a simple app that shows where all the power lines are so that all operators can plan their work before they go there and don't run the risk of of moving into a position and elevating the machine, whether it's a boom lift or any other type of machine, and elevating it and becoming electrocuted. We know that that's a significant issue, and we can see that having the information available is certainly something that's going to improve the worker safety. I'm going to really switch it up a little bit here. This is not so much about the machines themselves, and it probably addresses more at an OEM level. And we'll hear later today about ESG and the importance of keeping not just the importance of social governance. We like to care about the worker safety, but it's not just our own staff. We also got to consider our suppliers and their suppliers, and being able to track that we have a supply chain that doesn't use modern slavery, and improve. And how does AI work with that? I mean, it's obviously a very difficult process, and we're not using AI with this at all. But it's something that I see was coming through and is starting to become available, is being able to use all of the data. It's particularly about, I said, follow the money, is tracking the bank usage, tracking the people's movements to identify where workers are probably put into a case of modern slavery. All right, so where they're working but they're in indebted bonds. And so there's some complex investigations coming through that's using data fusion, taking information from all manner of places, not just from the banking industry, but from all different types of other social mechanisms to then make sure that there's no slavery going on. We'll probably start to see that there's a higher interest in making sure that suppliers are following the working practices that we would expect. All right, so most of those things are available and starting to become into usage. What I like to think is that in the next few years, or perhaps in the next 5, 10 years, things are going to change considerably. So this is a bit of a look forward to see that how the work sites are going to become more connected, how machines are going to become more integrated, and what that would hold, and particularly what impact that can have for the wider industry, for the wider access industry. And one of the things we look at here is say, what are the issues we need to address? Right? It's all well and good to say, right, we've got a whole lot of information, but what are the issues that we need to address? Because if we're going to connect through. And a few of these here are of some suggestions about what we can look forward to, and perhaps what is needed. And these are driven particularly by IPAF. I'm not sure if you're aware, IPAF runs an accident reporting program and identifies across the wide industry where there are core issues. And one of those is when MEWPs work alongside the road and they're at risk of being hit by vehicles, particularly trucks, etc. And it's all well and good to say, okay, well, we'll just try and put up some witches, some traffic cones, and hope that the operator is protected. Well, but with the advent of sensors and better and control technology, we can perhaps ensure that the boom arm doesn't come across over into the roadway and doesn't come across into that line of traffic path. Another point is overturning, a big issue for MEWPs. In Australia, just recently, a judicial inquiry identified where there's a large truck mount overturned, unfortunately caused 2 fatalities, and it was on a construction site, and a ground condition report had been done by a geotech engineer. But of course, that information had not been made available to the operator. And unfortunately, there was a thin crust on the ground, and so the operator thought it was sufficient ground to load them, to raise the machine up. But one of the outriggers burst through that thin crust, and it overturned. So we have the information if we think it globally, we have the information on what the ground is and what the condition of the ground is. But how do we get that information to the operator? How do we get the information to say that there's some services underneath this roadworks that the machine's going to be travelling on? And how can we start to better protect the machines for preventing overturning? This is quite pie in the sky at the moment, but I tend to suggest that in 10 years' time, with a better integration, that we can start to take some of this information and bring it to use. And I keep going about it's very important to have a better interface. And we can see that when we use MEWPs, one of the high risk areas, excuse me, is during the rescue. During a rescue operation, if someone is stranded at height, and you have people who are not necessarily trained having to retrieve the platform. Or it could be just simply that operators jumping from machine to machine and they're not adequately trained or they're not adequately familiarised with the machine. So how can we better control movement? How can we use systems to better introduce and to train the operator on how to use that machine? Now, I'm not at all suggesting that we move away from training, but perhaps a simple chatbot. Hoping there's no video. Maybe there's a chatbot that comes onto the machine, right? Unfortunately, there's no audio. But just a little idea of saying, okay, something that maybe Jeannie might want to introduce is, on their screens, if you have someone need to do a rescue, a chatbot will come up to you and tell you how to do it. Right? Probably not going to happen, but there's a futures ahead of us. All in all, what we have is we have the information out there. We have the technology, but what is tremendously important is how we integrate that in and to make it useful for the operator and make it useful for all workers on the site. Bringing the technology and making it usable for the human. I think that's something that underpins how we need to move forward with AI and how it is going to improve both our safety and also the productivity. Thank you all. Do appreciate the time.
Thank you, Andrew. I'd like to open the floor up to questions. Anyone? Well, if you think of something along the way, Andrew will be around and we'll have a break later on and you can surely pick his brain.